How airplane engine works? I know all of us are thinking, how an cylindrical big noisy thing. In the plane's wing works, there are many types of an airplane engine. First, the turbofan engine. A turbofan engine, which the most widely used airplane engine in aviation industry nowadays, because it's more efficient than the other, and its long-range capabilities. Second, the turboprop engine. Turboprop engine mostly used by military, because of its reliability and fuel efficient. But airlines barely use this type of an engine, because of its short-range capabilities. Our fourth engine is the turboshaft engine. This is another form of gas turbine engine that operates much like a turboprop system, but it does not drive a propeller. Instead, it provides power for a helicopter rotor. In short, it is an helicopter engine. Our next engine is the most marvelous engine in our list, the ramjet. The ramjet is the most simple engine but has the capability to push in the hypersonic speed. It is the simplest engine because it has no moving parts. But for now, we will just focus in the most common engine, the turbofan engine. A turbofan engine has a large fan at the front which sucks air. Most of the air flows around outside of the engine body, making it quieter and give more thrust at low speed. Most of today's airliners are powered by turbofan engines. In a turbojet, all of the air entering in the intake passes through the gas generator, which is composed of the compressor, combustion chamber, and turbine. In a turbofan engine, only a portion of air goes into the combustion chamber. The remaining passes through a fan, or low-pressure compressor, and it is ejected directly as a cold gas or mixed with the gas generator exhaust to produce a hot gas. The objective of this sort of bypass system is to increase thrust without increasing fuel consumption. It achieves this by increasing the total air mass flow and reducing the velocity within the same total energy supply. The objective of this sort of bypass system is to increase thrust without increasing fuel consumption. It achieves this by increasing the total air mass flow and reducing the velocity within the same total energy supply. To move an airplane through the air, thrust is generated by some kind of propulsion system. Most modern airliners use turbofan engines because of their high thrust and good fuel efficiency. On this page, we will discuss some of the fundamentals of turbofan engines. A turbofan engine is the most modern variation of the basic gas turbine engine. With other gas turbines, there is a core engine, whose parts and operation are discussed on a separate page. In the turbofan engine, the core engine is surrounded by a fan in the front and an additional turbine at the rear. The fan and fan turbine are composed of many blades like the core compressor and core turbine and are connected to an additional shaft. All of this additional turbo machinery is colored green on the schematic. With the core compressor and turbine, some of the fan blades turn with the shaft and some blades remain stationary. The fan shaft passes through the core shaft for mechanical reasons. This type of arrangement is called a two-spool engine, one spool for the fan, one spool for the core. Some advanced engines have additional spools for even higher efficiency. How does a turbofan engine work? The incoming air is captured by the engine inlet. Some of the incoming air passes through the fan and continues on into the core compressor and then the burner, where it is mixed with fuel and combustion occurs. The hot exhaust passes through the core and fan turbines, and then out the nozzle. As in a basic turbojet, the rest of the incoming air passes through the fan and bypasses or goes around the engine, just like the air through a propeller. The air that goes through the fan has a velocity that is slightly increased from free stream. So a turbofan gets some of its thrust from the core and some of its thrust from the fan. The ratio of the air that goes around the engine to the air that goes through the core is called the bypass ratio, because the fuel flow rate for the core is changed only a small amount by the addition of the fan. A turbofan generates more thrust for nearly the same amount of fuel used by the core. This means that a turbofan is very fuel efficient. In fact, high bypass ratio turbofans are nearly as fuel efficient as turboprops. Because the fan is enclosed by the inlet and is composed of many blades, it can operate efficiently at higher speeds than a simple propeller. That is why turbofans are found on high-speed transports and propellers are used on low-speed transports. Low bypass ratio turbofans are still more fuel efficient than basic turbojets. Many Modern fighter planes actually use low bypass ratio turbofans, equipped with afterburners. They can then cruise efficiently but still have high thrust when dogfighting. Even though the fighter plane can fly much faster than the speed of sound, the air going into the engine must travel less than the speed of sound for high efficiency. Therefore, the airplane inlet slows the air down from supersonic speeds. The mathematics describing the thrust of a turbofan engine is given on a separate slide.